Hello everyone, welcome to my channel. In this video, I will explain about factor analysis. First we'll see the definition. Factor analysis is a statistical technique used to identify hidden factors, which is also called as latent variables. It is used to reduce the large number of variables into few meaningful groups. So what is the meaning of this factor analysis? Remember all of you, it is a statistical technique. So it is a statistical technique. What is the purpose of this factor analysis? It is used to identify hidden factors. So by using factor analysis, we can identify the hidden factors. Hidden factors are also called as a latent variables. And second one is it is used to reduce the large number of variables into few meaningful groups. Okay, so if you observe the factor analysis, there are two main applications are there. The first one is called as it is used to identify the hidden factors, and second one is it is used to reduce the large number of variables into few meaningful groups. Okay, so this is called as what we say factor analysis. Let us see that example. By the way, we'll get more clarity. So you can observe on the screen. So what is the meaning of this factor analysis? So the example is you can observe there are, let us say, 20 survey questions are there. So there are 20 survey questions are there. So what I am going to do, I am going to divide these 20 survey questions into 3 factors. So what is the use of this 3 factors? When survey questions 20 are there, we may get some confusion. But when I have 20 survey questions, if I divide into 3 factors based on attitude, satisfaction and behavior, these 20 survey questions will come into, some of the questions will come to attitude, some of the questions will come to satisfaction, and some of the questions will come to behavior. So what is going to be happened? We'll get some a good idea. So the questions are very clear. So this is called as what we say, we are going to identify the factor analysis. Okay, so 20 survey questions will be divided into 3 factors based on attitude, satisfaction and behavior. Now we'll see the objectives of factor analysis. So what are the objectives are there for factor analysis? First one is called as dimensionality reduction, and second one is called as identify hidden patterns, third one is called as data summarization, and last one is called as improve model performance. Okay, so the main objective of factor analysis, we are going to have dimensionality reduction. So we are going to reduce the dimensionality of the data. We are going to identify hidden patterns. Okay, so we can summarize the data and we can improve the model. So these are called as objectives of factor analysis. Now let us see what are the important key terms related to this factor analysis. So first one is called as factor. So what is the purpose of this factor? It is nothing but it is a hidden variable. Second one is the factor loading. So it is the relationship with the strength. Third one is the eigenvalue. It is a variance explained by the factor. Okay, so what is eigenvalue? It is nothing but it is a variance which is explained by the factor. Next one is the community. It is nothing but it will explain the variance. So screen plot, it is a graph to find the number of factors. So what is the purpose of this screen plot? We are going to find out the number of factors. So next we are going to have KMO test, which is used for data suitability, and last one is the data rotation. It is used for simplify the interpretation. So these are main important key factors of factor analysis. Now we'll see what are the types of factor analysis. Most important point in this slide. So that is, first one is called as EFA. What is EFA? Exploratory factor analysis. Second one is the CFA, which is called as confirmatory factor analysis. So what is the use of this exploratory factor analysis? It is used when the structure is unknown. When the structure is unknown, we will use EFA, which is called as exploratory factor analysis. when the structure is known, we'll use this confirmatory factor analysis. Okay, but if you observe this exploratory factor analysis, find the patterns automatically. But if you observe this confirmatory factor analysis, it tests the hypothesis or model. So these are called as different types of factor analysis. Next we will see the steps. So what are the steps required to find the factor analysis? So first one is the step 1. This is the check data suitability. So first we are going to check the data suitability. So in order to check data suitability, we are going to use two methods. First one is called as KMO test and second one is called as a Bartlett test. When you observe this KMO test, you can observe this full form Kaiser-Meyer-Olkin. So when we do this KMO test, we are using this formula. So what is this formula? KMO is equal to sigma r square by sigma r square plus sigma p square. So this is called as the formula related to KMO test. We are not going in depth, but remember it is used to check the data suitability. Okay, so what is this R over here? R nothing but correlation between variables and P is the partial correlation. Okay, so after completion of the result, if we get, so after completion of this KMO test, if we get the answers like, if you can see, observe on the screen, if the value of KMO is greater than 0.6, we can say that is called as acceptable. If it is less than 0.5, this is called as a reject. Okay, so if the answer is 0.6, we can say acceptable. Less than 0.5, we can say this is called as a reject. So remember, there are different values are there. If we get the value could be 0.8 plus, this is called as good. If we get 0.6 plus, we can say this is called as acceptable, and this is called as 0.5 is less than, this is called as 0.5, which is called as a poor. So poor means less than 0.5. Acceptable means the value in between. Here you can see 0.6 plus. So if we get 0.8 plus, this is called as a good. So these are called as a KMO test values. So variables should share common factors. So second one, what we have? Second one is the Bartlett test. So what is this Bartlett test? It is going to check the correlation significance. Okay, so it is going to check the correlation of the significance. So if we find the probability value, if we get less than 0.05, this is called as suitable. If it is greater than 0.05, this is not suitable. Variables must be correlated, means one variable must be related with the other variable. Okay, now you observe. So first one is the check data suitability. So in order to check data suitability, we are using two methods. First one is KMO test and second one is called as a Bartlett test. And you can observe second one is the choose extraction method. So after completion of the suitable getting the data values, this first point is here, this value, check the data suitability. Then we go for step 2. So what is this step 2? We are going to have check extraction method. So we are going to choose the extraction method. So there are two extraction methods are there. First one is called as PCA and second one is called as PAF. So PCA is called as principal component analysis. It is used for data reduction. So what is the meaning of data reduction? When there is a large amount of data, we are going to reduce the data. And second method is PAF, principal axis factoring. It is used to identify hidden factors. Okay, so this is about the step 2. In the third step, we are going to have factor extraction. Extract the factors using eigenvalues. Keep factors with eigenvalue greater than 1. So when we find the eigenvalues, when we have this value should be greater than 1, when we get value is greater than 1, we are going to keep those values and remove other values. Okay, so extract factors using eigenvalues. And fourth one is the determine the number of factors. Okay, so first, second, third completed. Now we go for fourth one. This is called as determine the number of factors. So in order to determine the number of factors, we are using here the concept called as a Scree plot. So what is this Scree plot? It is nothing but you are going to have plot eigenvalues versus factors. So we are going to find the elbow point and keep factors before elbow. Okay, so we are going to keep the factors before the elbow. And fifth one is the factor rotation. Okay, so how to rotate this factor? It makes interpretation easy. So what is the purpose of this one? It makes the interpretation easy. So we are using here Varimax. Okay, so this is the most common mechanism in factor rotation. So this is called as a factors uncorrelated. So we are using, when the factors are not related, we are using the concept called as Varimax. But if you see Promax, we are using this concept when the factors are correlated in order to perform this factor rotation. And sixth one we have on the screen, this is called as interpretation. So what is the meaning of interpretation? Assign meaning to the factors. Okay, so example, let us say the values are factor 1 is, the factor 1 value is performance and factor 2 value is satisfaction. So based on performance, I am going to divide the data. Based on satisfaction, I divide the data. This is called as what we say interpretation. Now we'll see what are the extraction methods we have. So there are three methods are there. First one is called as PCA, second one is called as common factor analysis, and third one is called as a canonical factor analysis. So what is the purpose of this one? It uses total variance PCA. It is used for best for reduction. But when we say common factor analysis, it uses shared variance. So it uses total shared variance. It is best for latent factors. Where we are using for latent factors. And third one is the canonical factor analysis. It is based on canonical correlation. Okay. Now, what are the assumptions related to this factor analysis? So first one is the linearity, second one is the normal distribution, third one is the no multicollinearity, and the fourth one is the homoscedasticity, and next one is the independent observations. So these are called as assumptions. And what are the applications of this factor analysis? Where we are using, actually this is a marketing, physiology, psychology, this one. Okay, next one is the education, finance, healthcare. So these are major applications of this factor analysis. Now what are the advantages are there? Advantages could be it reduces data complexity. By using factor analysis, will reduce the data complexity. It identifies hidden patterns. It improves the model accuracy. And the last one is it removes the redundant variables. So what is the meaning of redundant variables? It is going to remove the duplicate variables. Okay. So now we'll see the limitations. What are the limitations of factor analysis? So that is, it needs large data set. It is sensitive to outliers, and interpretation can be difficult. And last one, it assumes the linear relationships. Okay. Let us see the example for factor analysis in order to get more clarity. So what is this one? Let us say the given variables are, you can observe, that is maths, physics, chemistry, English, history. Now we are going to divide this one. So what I am going to do? I am going to group similar subjects. Okay. So let us, if you observe on the screen, there are completely 5 subjects are there. So what I am going to do? I am going to say math, physics, chemistry are related. Yes. English, history are related. So what is the relation between maths, physics, chemistry? These are called as science subjects. So you can observe. So first one is the science factor, maths, physics, chemistry. But when it comes to arts factor, this is called as English and history. This is called as factor 2. It is called as factor 1. So this is called as a factor analysis. So final answer is, there are 2 factors identified, and first one is the science factor, second one is the arts factor. So this is about the factor analysis. Very important concept. Thank you for watching this video. Please subscribe my channel. Thank you one and all.